Hi, in this session we are beginning the part 4 of Unit 1. This is going to be the last part, so we are about to finish the Unit 1 and let us see what topics are included under Unit 1. The structure and uses of DDT, saccharine, BHC and chloramine has to be studied. So it's the most simplest part of the Unit 1. We have to study 4 compounds. We have to study the general introduction, the synthesis, the structure and the uses. So without further ado, let us start with compound number 1, which is DDT. I'm sure you have heard this name DDT. It was a thing which was used in the agricultural purpose. It was actually used as an insecticide in the agricultural work. The term is actually an abbreviation for a big name. The name is dichloro-diphenyl trichloroethane. So it's a big name, that is why an abbreviation was used for it. If you see it as a compound, then it was colorless, tasteless and almost odorless. The thing was discovered somewhere around 1950s and was discovered by a scientist, Paul Hermann Muller. And the discovery was so great that he was awarded Nobel Prize for its discovery in 1948. The beauty about DDT was it was a contact poison for several arthropods. Arthropods actually a family name for the insects. So all the insects belong to this particular family. So this DDT was a very effective poison for these insects. So you simply need to spray DDT over the insects, then the insects get killed. So it was a very amazing discovery. It found use in agricultural work, so insects could not harm the crop. You can see the images that it was used at a very large scale worldwide, and the human exposure was not taken care of. You can also see the DDT is actually getting sprayed on the swimmers directly in the swimming pool. So it was understood to be a safe compound that could be used for its insecticidal properties. But in the later years, roughly around 60 years of its use, it was found that this thing is very notorious. It became famous for its environmental impact. We will discuss this thing later on. So let us now study the compound from the chemistry point of view. If you see its structure, then it is made up of one carbon in the center, and attached to this carbon are two identical groups which are chlorobenzene. So there is one chlorobenzene on this side, and as a replica there is another chlorobenzene on the other side, and there is also attached the CCl3 group. CCl3 can be combinedly called as trichloromethyl. It is similar to a methyl group, but all the hydrogens are replaced with the chloro group. So that is the only change. So trichloromethyl group is also attached to this carbon, and the fourth group is not mentioned, but that fourth group is hydrogen. So this is the complete structure of DDT. The IUPAC name is not really necessary to be written in theory exams, but sometimes in competitive exams questions are asked on IUPAC name. So you must pay attention to it, that this term is used because there is identical 4-chlorobenzene which is attached to this particular carbon, and this 2,2,2-trichloroethane because this carbon is considered as the prime carbon and this is the second carbon. So on second position itself 2,2,2-trichloroethane is mentioned. So you should pay attention to the IUPAC name. So when in competitive exams, if question is asked, you can select the right option out of the 4. It's a man-made compound. It is not found naturally in anything. It was a man-made compound discovered by Paul Hermann Muller. The method of preparation includes reaction between chlorobenzene and chloral. Chlorobenzene is nothing but benzene with one chloro group. So we are taking 2 molecules of it, and the third molecule is chloral. Chloral is nothing but your acetaldehyde which is having all three hydrogens replaced with chlorine. So you write the structure of acetaldehyde and you replace all the hydrogens with chlorine, so this becomes chloral. You react these three molecules together in the presence of acid catalyst, then this gives your DDT. This oxygen carbon double bond is getting broken and two new single bonds are getting formed with these site of attachments of benzene. So this is your DDT. I've already told you the use. It was a powerful insecticide that became popular in the late 1950s and in World War II, and after that it was used at a very large scale. It was found to be effective against a lot of insects such as lice, fleas, mosquitoes. So all these things are nothing but insects of one kind. So mosquitoes are also observed to be carriers of various diseases that cause infection in humans such as plague, malaria, typhus, yellow fever. So this DDT compound was getting used to kill mosquitoes because the mosquitoes are the reason that such infective diseases get spread. It was used on a very big scale, and it was also used as the insecticide to protect crops against insects. So you can see the use that was there before the year 2004, before this compound was actually banned. It still finds some use in limited amount, simply to be used as to prevent the growth of mosquitoes and other carriers of diseases, because it's a very cheap insecticide. The side effect of DDT, the reason because it was banned, was it was very toxic to human beings and mammals. Let me show you. If you see the side effects of DDT on human, then the side effect looks quite normal, that it causes nausea, headache, fatigue, confusion, abdominal pain, dizziness. Very simple side effects. Any chemical exposure you get the same type of side effects. But the real problem with DDT was, suppose you spray DDT in water, the concentration of DDT in water is very less. You suppose that the concentration is very less, but it gets accumulated in small insects of the water. Then these small living beings in water are eaten by the small fishes, and the DDT which was there in these small living organisms gets accumulated to the small fish, and the concentration rises because it is eating a lot of them. And as DDT is not biodegradable, that means no mammalian body can digest it, so it keeps on accumulating. And if this small fish is eaten by fish eating birds or any other big fish, then it's tend to get accumulated over the series. So the final eater, like birds, can have 10 million times more concentration of DDT than the one which was sprayed in water. So you can see that bioaccumulation and biomagnification was the actual reason that DDT was not safe for the environment, because no living body can actually digest DDT. That was the reason that it got banned in the year 2004. So I hope you have got a very well idea about the compound DDT. You have got the structure, you have got the introduction, you got that the compound was so famous that the discoverer was awarded Nobel Prize for it. You got the method of preparation in terms of chemical synthesis, the uses and the side effects, with the reason that it was banned in the year 2004 and not used with that large scale as today, and but still find some of its use in stopping the diseases. Okay, so that's it for this video. In the next video we are going to take the second compound, which is benzene hexachloride.